Okay, hello everyone. I'm just going to confirm that everything actually works. I guess you can still hear the echo music from the YouTube because I'm not on my headphones today. But yeah, in 3 seconds I will be able to confirm if the microphone works. And it does. Perfect. Okay. So, welcome everyone. And this week we are going to do basically the same thing we did last week. So last week I talked about nanomites, which is actually like the debugger scheme of anti-reverse engineering. Well, anti-reverse engineering trick. And I've implemented it on Windows using the Windows API, the Win API debugging interface. And today I'm going to do the same thing basically, but I'm going to do it on Linux using the Linux debugging interface, which is actually ptrace. So I guess that's kind of more like, I'm not sure if that's ptrace is like a Linux debugging interface. Is it POSIX interface or is it like a general Unix one? I actually don't know. Well, but Linux uses ptrace for debugging usually, so I will use that as well. And yeah, for example, like GDB uses that, strace uses that, and so on and so on. So is the normal interface for debugging on Linux. As usual, I will start. Oh, there's a donation from Sebastian. Thank you and hi. Yeah, so I will, as usually, start. I guess, well, today not 15 past. Let's start 5 past today because I want to make the stream a little shorter today. It's, yeah, one of the reasons is that it's really hot here, like 30 degrees in the room, I think. Well, some of you might say, that's nothing. We have like 40 degrees centigrade, Celsius, sorry, in the room, and yeah, but I'm not really used to that. So you can see that robot-looking thing somewhere, where is it? Oh, here, that's actually a fan. If the fan blows into the microphone, please let me know. I will disable it. But I think it should be fine-ish. I'm actually in the way, so it should be fine. Okay, so let's do some questions. Let's do some usual updates, and then in a couple of minutes we will start. Okay, so let's start with my desktop. And my moderator today is, as usual, KrzaQ. And KrzaQ, this is his blog post. Well, blog. dev.krzaQ.cc. And this is his blog post from April. Hey, KrzaQ, what's up with that? Why is it April? I mean, it's August. It's already 2 to the power of 3. So if you're doing blog posts every power of 3, now is the time to do it. Yeah, but you should visit his website any case. Now, my Genva Summer Game Dev Challenge is still running, and I did some rule change. Well, not really a change in the rule. I added some clarifications to the rule after last stream. So if you're taking part, you might want to take a look at what was added. I think this was added. It basically says that, yeah, you can use the default mouse cursor and it doesn't count into the color limit. So yeah, because I was asked about that. So it's really, I guess, interesting when it comes to the rules, because I did try to be somewhat specific, well, pretty specific, but there are always, questions which actually point out something which is not defined by the specification, by the rules in this case. And when making a decision whether something is supposed to be allowed, I'm trying to not exclude people who might actually rely on a given functionality. So I did allow the default CSS mouse cursors to be used, though not the own mouse cursors using the CSS. You can have your own mouse cursor using canvas, like drawing on the canvas. That's totally fine, as long as it's the game canvas. So yeah, if you're taking part in the competition, do look at this page from time to time. I added a counter that will actually tell you when was the rule update. I'm trying not to update the rules too much, and there is always an FAQ added about why the rule was changed and why was the decision which I made like this. So that's that. You still have, I think, yeah, you still have 2 weeks, almost, no, 10 days-ish, 10, 11 days to finish and submit the games, and some games were already submitted. Just a short reminder that there are also prizes from 200 USDs in that's actually in a gift card for Amazon, Steam, or if you have another idea and you win, then do let me know. We can discuss it. Yeah, it will be considered at a per case basis, as noted here. So yeah, 3 awards from 2,000, 150, 100, and perhaps maybe 0 or maybe more honorary awards from which are $50. So that's that. Then yeah, I'm going to see if there are any questions. If not, then we can get going with today's topic. There's one question. Let me show it to you. You will see it. You will see it there. I did mention already that KrzaQ is today's moderator, but if you have any questions, especially on YouTube chat, do write to KrzaQ. His nickname is right here, like below this window. Make an @ then KrzaQ space KQ and write your question, because that way the question will reach me. I am not looking at the chat too much for obvious reasons, right? I'm trying, to code, and looking at the chat might be a little distracting. So that's where KrzaQ comes in, and he actually makes sure that all the questions reach me and all the important comments and so on. So, okay, first question is from Mirek, and that's actually, I think, a question from last week, which I didn't answer. Did you hear about last revelation, the God mode in x86? What do you think about it? So this is about the backdoor in x86 CPUs, and before you get like really, whoa, a backdoor in x86, that's crazy. It's not in Intel, it's not in AMD, it's in VIA CPUs. So Intel and AMD are not the only manufacturers of x86. Historically, there have been, like, I don't know, 20 other companies which made x86. The longest standing one was VIA, VIA. They usually do chipsets for the motherboard, but they also made their own x86 CPUs. I even have one computer somewhere of them, like a small mini PC. And yeah, so I think well, I don't remember who, but someone did CPU fuzzing, like instruction fuzzing, using, I think, SandSift or a similar tool like that. And they found that, hey, if you use this instruction, you actually suddenly jump from ring 3 to ring 0 to kernel mode. Like, just like that. Your code continues execution in the other mode, which is quite crazy. There's actually a little more to it when it comes to the details about this backdoor, but that's the gist of it. Now, it wasn't super critical. So the idea behind it is that it was supposed, I think, to be like somewhat of a documented debugging feature, and it was actually in the documentation. But and it was supposed to be disabled on deployed machines, but somebody forgot to disable it in BIOS, and yeah, this happened. So yeah, it's definitely not great. It's actually really bad. Thankfully, it was VIA, it was not Intel, it was not AMD, and yeah, most of, I guess, the CPUs of VIA were in embedded stuff or in like, mini PCs, so not the default thing you have your server running on. That being said, I actually had a server running on this, but I need to check if my old VIA PC is actually vulnerable to this. If it is, we might want to play with it at some stream, because why not? So yeah, that's pretty interesting research, actually, and I'm pretty happy that something like that was finally discovered. Finally, we know that, yeah, the backdoors in the CPU, yeah, they are there. Well, documented, but whatever. Cool. Okay, so I guess that was the last question, unless somebody okay. Unless somebody has another question. If not, we can. I guess we can get going with the Linux code today. So just as a recap from last week, what we did. Wait, let me start. This will be a Linux console. It has black background in case you're confused. And this is a Windows console. It has a photo of Zurichse, actually. Okay, and yeah, the code is like this. We had the main function, which I'm going to modify, I guess. Was like this. Basically, you run it, and you assume that it will spawn a child, like a child process, which will be itself, like the same executable. And to determine whether the executable which is running, the process which is running, is the parent or the child, it uses just an environment variable. There are a lot of ways to do it. There are better ways to do it than using an environment variable, like for example creating a global mutex. But yeah, it's one of the ways to do it. Now, yeah, if this is not set, therefore it's the parent, and the debugger tree is called, the debugger function is called. If the environment variable was set, then the debuggee, well, the child, is called. Now, if we look at the debuggee, it was actually, well, pretty simple, right? It was one function, it displayed some stuff, but in the end it added two numbers together. And the idea is that adding the two numbers together is not going to be using a straightforward operation. We want to obfuscate it a little, and the obfuscation in this case works like this, that the child actually passes the work to the parent using the debugger interface as a weird sort of an inter-process communication scheme. Now, this was done basically using the UD2 instruction, which is undefined opcode. It's a, yeah, I was like joking, but it's the opcode, a defined opcode which issues an undefined opcode fault, CPU fault. That's actually what's happening. So the idea here is that it can be anything which issues a signal to the debugger. In this case, it's this instruction, which will issue a CPU fault to the debugger, or actually to the kernel, and the kernel will check, hey, this process, does it have a debugger attached? Yes, it has. It's this process. So it passes the information to the debugger process, and it gets an event, right? And the event handling looked like this. The code is on GitHub, by the way, on my GitHub, like github.com/gunveil/stream-en. Or maybe that dash isn't there, well, or whatever, you will find it. So this is basically the event loop for the debugging events. It waits for a debug event, and then it processes the debug event. And there are several of them, but the one we care about is handle exception. Handle an exception which happened inside the child process. So this function is then is here, and what we do is we get the thread context, we get the registers, the values of, the RIB register and so on of the child process. We check if it's like equal to an area where we expect our executable to be. Then we check whether we read the memory from the instruction pointer. Again, the instruction pointer is pointing to UD2, which has this value. And sorry. So we check if it's actually UD2, and if it is UD2, we get two registers, which is RDX, RCX. We add them together because, again, the function we want to do is actually adding two numbers together. We put the result in the RAX register. We increment the instruction pointer by 2 because UD2 is 2, and the incrementation is not done automatically in this case. We set the registers for the child process, and we exit, and later on actually continue execution of the child process. Is happening here, continue the debug event, which means continue, let the child process run. And so we return here, and we are here, like this instruction executed, the RIP, the instruction pointer, moved to the next instruction. The RAX has the sum of these two arguments right now, and it returns to the to here, and basically the print outputs the result, and this is what we implemented last time, and this is how one of the ways this debugger scheme might work. But again, usually you don't want to add two numbers, right? You want to take an important piece of your code and like split it into two parts. One is in the debugger, in the parent, and the other is in the child, in the debuggee, and therefore it makes it harder to analyze, especially if you like clear memory and so on. So like, for example, there is no parent memory in the child and so on, or use some additional obfuscation layers. So this is it. Now what we are going to do today is basically do the same. I'm actually going to reuse this code, but we are going to do it on Linux. So we are not going to use the Win API. We are going to use ptrace API, as I did mention. So I already did a copy of these files. I am going to remove everything which is Windows related and replace it with Linux related stuff. And I guess I'm going to start with creating a compilation script. I did create I actually did do it command line style, but I will create go.sh, which will, handle the compilation and so on. So let's start with this, bin bash, now I'm going to do set dash, I always forget, is it X or is it E? Let's do both. One is, I think E is echo the command, and X is if one of the commands returns non-zero value. For example, there would be an error in G++, then exit the script early. We can test which one is which in a second. And the other one is, again, just output the command. Now I'm going to change the name into nano without an extension, because of course on Linux we do not use extensions. We use, you might say we use attributes for files, but on Windows we also use attributes for file, just like every file has executable for some reason. And on Linux that is not the case. I guess we can run it like the one we had compiled last time. It prints everything, it gets the result. We are adding, I think, 123 plus 222, 222, and this is the result, and then both of them exit, and we are going to try to do the same on Linux. Obviously, if I would try to compile it on Linux, it doesn't work. We can, let's just do go sh will execute without me setting the execution attribute, just because this is on a mounted partition through VirtualBox on, they're basically like VirtualBox partition, and for some reason all the files ever have executable attributes, so I don't have to set it. It says like Windows missing, blah blah blah. Just like a funny thing, if you'd want to compile an application for Windows being on Linux, you can obviously use minf. I don't think I have minf installed right now, but there's minw, the compiler I'm using on Windows, is also for Linux, and you can do cross compilation, which is sometimes useful because surprisingly sometimes it's easier to compile an open source application for Windows doing a cross compilation from Linux. At least that's my experience. Okay, so yeah, let's. I did say that I'm. Oh, by the way, the echo here is like this. So I'm going to check which one is echo, and I'm going to remove echo. That's echo. No, X is echo. Yeah. So E is going to stay here. This is fine. So please note that if I add something like echo AAA here, right? And if I go again, the AAA is not displayed. We do not see AAA here. If I'm going to comment this set-E option, it's a bash option, it's a bash feature of a bash interpreter. If I run it this way, then it actually doesn't exit early in case of an error, and it does display this, but this is a compilation script, so we want it to behave like makefile basically, so exit early in case something goes wrong. Though, yeah, this is just like, just a random tidbit of information, because it doesn't matter, we just have one line of compilation. Anyway, if we would have more then it probably would make sense to make a makefile or a Python script to build it, but yeah, whatever. So, okay, this can stay, like get and this is fine. It's also available on Linux. There is nothing in this file which is Windows specific. We can leave it. We do not need to change anything here. This also is totally universal. My Linux is running on a virtual machine on the same architecture. UD2 is also there, so that's fine. There's nothing which would require changing here, so that's fine. So yeah, we will not edit this file either. I'm going to keep it open. Now this file, debugger.cc, oh by the way, we do have two header files, which I don't think there's anything interesting there. Let's see. Yeah, debugger h. No, not interesting. And sorry, that was debuggy.h, and this is debugger.h. Yeah, debugger.h. Sure. No, yeah, this is also like we do not have to tweak it in any way. It's fine. Here, however, we do have to remove some stuff. Handle exception, we can kinda leave parts of it. I'm going to, I guess, comment out the stuff for now, just because we will have to like replace the functionality, right? So I commented it out. Well, the arguments are obviously going away because we need to use Linux compatible arguments, so this goes away. Here, putenv is actually not used on Linux. On Linux, we use setenv. You might remember me being confused about this on on last stream, right? So setenv, then name, value, and whether to overwrite. I guess that's the meaning of the last one. So let me just double check what does overwrite mean in this case. If overwrite is non-zero, okay, so if name does exist in the environment, then its value is changed to the value. If overwrite is non-zero, if overwrite is 0, the name is not changed. Yeah, I don't care either way, actually, because I'm going to be running this function only if the environment variable was never defined. So I'm doing a setenv here, and the value is actually in another parameter, right? So it's a little different than putenv. So that's that. Then, well, starting the process is a totally different thing. I'm going to note what do we have to do. So first, start the process, and I am going to remove it. And please note that the process is being debugged, right? Debug process. So it's actually start the process and debug it. By debug it, I mean attach yourself as a debugger. Then we have the events and we have the threads. I don't think the threads will be super important on Linux. Linux doesn't span the amount of threads that Windows does by default, so I think we'll be fine with it, but just in case I'm going to leave this to remember about it. And then we have like the environment loop, right? So to environment, debugger loop, obviously. Debugger event loop, yeah, not the environment loop. There is no such thing as an environment loop, unless I'm missing something. Okay, so this is the part which we will actually have to code, and I'm going to try to compile it now. It still complains about stuff. For example, oh wow, I do have an old GCC here. G++ 7.2. Well, 7.2 isn't bad, but it seems that, yeah, naked attribute is ignored. This is not good. It means that this is actually ignored, so I'm going to use the other way to make a function like this. I'm using C++, which is kind of annoying, but we can get around that. Okay, so you might remember me googling a funny phrase last time. I'm not going to... yeah, I'm not going to Google it this time. I'm just going to enter my blog and look for the blog post I want. A blog post about the naked attributes and functions. It's actually quite easy because it's one of the first entries on my blog. Let me do... no, that's fine. Okay. Wait, just loaded. Here, naked functions, and we are going to do this basically. So this is if the naked attribute doesn't work. Again, the naked attribute, as I showed last time, if you don't remember, then check out the last stream, basically makes the compiler not add any additional code here or here. All the functions are only the things which are here, but usually the compiler adds a prologue and an epilogue. And naked makes the compiler not do that. So I do have to do it in a different way. I'm going to go with extern C. If you're wondering, like, what is this about? This is about naked not being supported on x86 on GCC until version 8 0 or something like that. It was supported on some other architectures before, but for some reason not on x86. That being said, Visual C++, for example, supported the naked. So it's not about the placement of the attribute, it's actually about it being supported. Though, okay, so Hookers actually suggests trying to move the attribute. I can try it. I mean, I don't mind learning a new thing. I always like learning a new thing. So as Hookers suggests, I'm going to move it here. And no, still directive ignored. So again, it's not about that. It's about the fact that, well, GCC didn't support it for this platform before. It did support it again for other platforms. Other being some really weird platforms, by the way. So I was going with extern C. Now, if you're wondering what does extern C mean in this case, and I'm actually, as you can see, I did remove the brackets, right? So that's fine. I'm going to comment this out for a second. This is a function declaration, it's not a function definition. I'm going to make it a little bit bigger. Extern C means the symbol for the function. Actually, it's a C-style symbol, it's not a C++ style symbol. Why is it important? Because one of the differences between C and C++ is that in C++ you have the ability to override a function. That means you can have several functions with the same name but different arguments, and the compiler will try to figure out, based on the arguments, which functions do you want to actually call. And that means that on the low level, if you look at your object file, or at your dynamic library, the C++ symbols actually need to have information about the arguments. So add two numbers would actually be followed by, it depends on the compiler, it's called mangling, by the way, C++ mangling. Yeah, name mangling, here we go. Blah, 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 C doesn't, yeah. Yeah, and depending on the compiler, for like, if there is like one int, you would get the name, and the name here is h, and this actually says like 1h means the name consists of one character, that character is h, and then comes the argument format, and this I would be an int, or IC in this case would be int and char. And so on. So I actually don't want this decoration to be there, I just want the symbol to be named h, and to do that you use this extern C. So yeah, I know that my symbol will be named add to number. And now I can go about creating a naked function as my blog post describes. So yeah, this isn't really, you use asm for that, so let me do this, let me just copy it and replace this, and the instructions I want to call are actually these two. Now, what asm directive does in GCC, it actually like literally copy paste this part into the assembly. So as you know, the compilation in GCC you don't compile stuff to binary, you compile it to assembly, and then an assembler like GNU assembler actually takes the file, which is outputted by the compiler, and assembles it, right, into the binary object file. And this part is actually will be like directly copied into proper place for the assembly, and it will be like injected into the assembly stream, which means this will create a function in the scope of assembly compilation or assembler assembling to create this symbol and create this function at the same time. And yeah, the two things are kind of identical. I do prefer the naked method, but this will work as well. Okay, compiling too few arguments, right, because, so my apologies, it was here, there was actually another argument saying whether it should be overwritten or not. Again, we don't care. Okay, wait, did I save the file? I didn't save the file. Now it's better. Now we have one more. Oh, I did save the file, just looked in the wrong place, never mind. Defined but not used, this is the sole one complaint left. That's fine, we don't care. So, I guess I can do one more thing here. Yeah, I'm thinking of actually checking if my... No, I know that add to numbers was generated correctly. Just to by the way show you that this actually is directly copied, I'm going to insert a comment in assembly style here, which is ASDF. Then I'm going to compile it, and then I'm going to actually compile it again, but yeah, I'm going to do -S, which means please show me the assembly file which you generated for the... So it would be for the debugger, debugee.s. Yeah. And now if we look for... Oh, we don't even have to look too far, it's already here. Yeah, it means that... This is basically the section which I've added, right? You can see the ASDF and it was like directly copied into the assembly stream. I'm wondering if it's fine. I actually need to add text here for it to be better. So I'm going to do this and do this. Text mean, please put this into the text section, because otherwise it would probably put it in the text section anyway, but just not to risk it. Let's leave it at that. Okay. Okay. Is the font okay now, by the way? Because I did see requests for it to be bigger. Cool. So we have this part now, again, the debugger. The first step is actually, creating a process, and on Linux we do it using fork, which creates a clone of the process which is already running. And pid equals fork. And fork is it works in a funny way. It actually returns, I think, 0. I don't do it too often in all honesty, but I think it returns 0 if it's the child, and otherwise it returns the PID. Yeah, PID of a child process is returned to the parent, and 0 to the child on failure is -1. But fork should not fail. I'm not going to check for a failure. I'm going to check if it's the child. So now we are in the child process. This is executed in the child process, and everything else is executed in the parent. So this is the parent. Now in the child, we actually make ourselves being debugged. That means that for some events, the kernel will look for a debugger and will notify the debugger, usually the parent. To do that, we call ptrace, which I did mention. I need to include this file though, so let's do just that. That's the ptrace interface. And we are calling ptrace already. We're going to call ptrace on ourselves. First, you tell it the type of request. So all the APIs we saw on Windows, like reading memory, reading registers, continuing an event, getting an event, all of these APIs are in this one function in ptrace, and you just type put here the type of thing you want to do. Do you want to get registers, or maybe you want to do something else? So yeah, I'm going to be calling ptrace quite a lot. And the thing I want to call is ptrace trace me, which it basically tells that, hey, I want to be debugged by whoever is observing me as the debugger. So this is our request. Now, if I remember correctly, I don't really have to do anything else here, like 000. Yeah, because PID, address, and data, the 3 other arguments are ignored. They are completely ignored, so I do not have to put anything here, here, or here, because it affects on yes, it doesn't have any parameters, so that's it. Now, I'm still running the cloned process, but what I really want is I want to execute the process and, start again from main, right? If I would like to be a little hackish, what I could do here is I could actually get rid totally of this, right? And I could just call debugee directly from here, which wouldn't be a bad thing. I might just do that. The other way to do it is calling execve on, the name of the executable, and that would get me again here. I should not call main by hand, because you cannot call the main function. I mean, it's technically possible, but that's against the standard. It's an undefined behavior. So since we did use the environment variable for Windows, let's just call the debugger function there. So we're calling this here, and I'm actually not going to set the environment variable, I am going to call the function here, and I'm going to return whatever it returns. Because again, I did fork. That means forking basically means that I had a process which was running, and at some point I decided I'm going to fork, and Linux created a new process which was an exact clone of my process, exact-ish clone. But let's go for exact clone for as much as we care at this point. And yeah, and so now we have two processes, and this is basically the basics of process execution on Linux. So yeah, we could fork, we could trace, and we can run the function now. Otherwise, we could do execve to run another executable in this process. Cool, and now in the parent we actually need to catch the events related to the child. Please note that in the parent we go like this. We go to here, and PID is actually not equals to 0, so we immediately start to execute this code. Yeah, so we need to get a ptrace event, and to get that we use wait PID, I think, yeah. We use basically wait PID. Wait PID. I'm going to include these two things. Oh, KrzaQ says that in C, he thinks that in C you can actually call main, but in C++ you cannot. That might be possible actually. I do remember seeing this in the C++ standard, not in the C standard, so KrzaQ might be right here. Okay, what do we do with wait PID? We give it a PID to wait for events to come from this PID. I think we can do like any PID here. We can tell it, yeah, we don't care, like any PID is fine. And it fills the status, and we can give it some options, and it returns the PID of a process which actually did the event. So if we would be, you know, a debugger for multiple processes, then we would probably do like, I don't remember the exact value, like -1 or something here. Yeah, -1. It's the, like, just listen for events from any process, but we do care especially about events from our child, so I'm going to wait PID for our child. Yeah, so I guess I'm going to do int. By the way, this is like PID t, but PID t is actually like int anyway, so yeah, whatever. Rat is equal to this PID, and now the status, I guess I'm going to initialize it to 0 because why not? And then there are some options. I don't actually know what options are available. Let's check it out. By default, wait PID waits only for terminated children, but this behavior is modifiable via the options argument as described below. Okay, so this is the PID. The options is a return immediately if no child has exited. Which is basically, you know, makes it a non-blocking API interface. Otherwise, this blocks the same way on Windows the wait for event blocked. Okay, so actually I retract what I said. We are going to use two APIs, like ptrace and wait PID. We might then read memory using another API, but we'll think about it. Okay, so untraced also return if a child has stopped. And continue also return if a stopped child has been resumed by delivery of sick count. I'm going to put 0 here, and we're going to see if anything works anyway. So I'm going to put this in the loop, in an infinite loop actually. You know, bool the end false, so while not the end. Yes, that's exactly what we wanted. At the end, do this, and here puts like, now we're going to print the information about what did we actually receive. So here I'm going to go with child PID is going to be like process ID, like this, is going to be PID, and here return is going to be this, and status is going to be this. Okay, so that's the return and the status, and I think I need to continue it somehow. I don't remember how. I do not care too much right now, so This is by the way the debugger loop, which I mentioned before. Let's see what happens now if something works. That's basically what I want to check. It says fork was not declared. Where's fork? Oh, you need yesterday. Okay. Yeah. Wait, what? Alright. The debugee was not declared. It was not declared. That is true. H. Then, sorry, I'm going to do like this, clear and. Okay. Yeah, because now I see where it actually begins. Handle exception is defined but not used. That's fine. I don't care about it right now. So, okay, clear, and I want to actually run it. So nano is the name. And yeah, something works. As you can see, this is the child PID when the child is starting, and we got the message, so it's already started. And then we got an event. So the PID was returned. We do not care about it, I guess, because we know who we are debugging, like which process we are debugging. And the status is like this, 1151. And the question is like, what is the status? So yeah, we have to figure it out. Wait, PID. Yeah, it gets kind of funny, I guess, because you have to use a set of macros to figure out what happened. And yeah, if it's not null, then blah blah blah, and this is the macros which you have to use. You can like figure out if it exited. Returns true if the child is normally terminated. So we can, I guess, see if the child was terminated by doing if status. If exited status, then yeah, like child exited. Again, by the way, if you have any questions for me, do ping KrzaQ, because KrzaQ is passing on the questions. I will look at the questions and when we have a couple of minutes, I guess, or at the end of the live stream in the worst case scenario. Okay, if a child has exited, then we can guess. I guess we can do this, like set the end to true, and that's cool. We can, by the way, get the status, like the return code, using this macro, but we do not care about that. Then, if the child has signaled, if the child has stopped, and something, if the child has continued. I do not remember how we continue the child. We will figure it out in a second. So I guess we can do it right now. I'm pretty sure there's like a ptrace something for that, because again, everything is about ptrace. How do we continue? Continue. Here we go. The traces causes the tracer to continue. Optionally ignoring. Oh yeah, ptrace count. This is what I was looking for. So we put it at the end. I'm just going to copy paste it. Yeah, I don't care about this. So the compiler figure out. Sometimes it's important to create literals and constants in the proper way. At this time. Cool, the PID is okay, and then we continue. So as you can see, the structure of the loop is basically pretty similar. We wait for the event and we continue for the event, like we had last time on Windows. So yeah, let's continue and let's see how many events we actually get. And we get quite a lot of events, and this is probably because the child has signaled, and we are on UD2, and yeah. But before we get there, I want to comment this out. Therefore, this event should not happen, and we should be able to verify the rest of our loop. So let's run it again, and yeah, as you can see, like the child has exited, and so the rest of the loop works fine. There aren't that many debugging events which are happening on Linux, you know, in comparison to Windows. As you remember, there were like threads created, libraries loaded, and some exceptions happening before you even reached main on Windows. This is not true on Linux. It's much more, you know, elegant actually on Linux. That's the word I'm looking for. So we can uncomment this, and now what we can do is we can check the event whether the child signaled, because we know that our nanomite instruction UD2, well, actually causes a signal to be generated. I don't remember which signal, but I guess we will have to figure it out in a second. And here I'm going to do actually like else if signaled, yeah, it's like W if signaled. That's like 3 words, right? That's how you're supposed to read it. If it's signaled, then we go here, and we know that the child has signaled. So child has signaled. I guess there is a way for us to get the signal. Returns the number of the signal that caused the child process to terminate, only if returns true. Yeah, okay. And signal status. Let's see how this works. And boom. It didn't signal, so that's not it. Man, ptrace. Not ptrace. So I'm pretty sure it will be about the stop signal in that case. So stopped. That's another event we can support. Child has stopped, and the reason for stopping is stop sick. Yeah. I guess if the child was terminated, then the end is supposed to be equal to true as well, so let's add support for that. Okay, and let's retry it. Okay, yeah, we're getting there. The child has stopped, and the reason was 4. Okay, I don't know what 4 is. I'm wondering if that's the signal. Let's read what does it mean. Stop sig. Returns the number of the signal. So yeah, this is the signal. So we're going to do man, what was it, 8 signal? Or 7 signal? 7 signal, and here are the numbers of our signals. We got 4. 4 is sig-ill. Sig-ill means illegal instruction. Again, UD2 generates the CPU fault for an undefined opcode. Undefined opcode, illegal instruction, same thing. Therefore, yeah, this is the signal which we were supposed to expect, so that's fine. What we will do here is we're going to check if s is equal to 4. Is there a, like, sig-ill? Can I do sig-ill? I want to do sig-ill. In that case, we are going to call this function, right? Handle exception, because we are already getting there. So handle exception, what do we need to pass it? We will need to pass it the PID. That's pretty obvious. And actually, that's about it. I don't think we need to pass anything else, like PID is enough. So, PID. Yeah, again, it should be like PID T, but, and whatever. Okay, so it will probably fail the compilation due to the reason that sig-ills will be undefined. Oh no, it compiled. That's funny. Okay. I actually expected it to say to me like, no, you need to include another header. So on Windows you had to include like windows.h, and that's usually about it. On Linux you have to include, yeah, like we already have, we needed to include this, and this. So I expected it truly to require another header. That's not the case, it seems. So we are going there, and here we need to do the same things. As you can see, we requested the context. Well, this is the whole block. Then we checked whether we are in somewhat the correct address space. We will have to do the same thing here. And then we'll have to do some other checks. So let's start with getting that context. And we use the ptrace API for that. There is like trace get regs. Yeah, here we go. Copy the traces general purpose or floating point registers, and this is exactly what we need. Okay, I noticed a question. Do I stream on Twitch as well? No, I did try that in the past, but that didn't work out too well, so I'm only on YouTube right now. I do have an account on Twitch, but it's not inactive, basically. I think there are like a couple of more questions or comments, but I will get to them after I'm done with this. It will take me, I don't know, a couple of more minutes, I guess, because we're getting there. So ptrace, then the request we want to make, then we have to pass it, the PID obviously, because we need, so sorry, was it the PID and then the request? Yeah, that's the correct way to do it. And now the arguments. For the arguments, we need to see, yes, sysuser, which is again the context. You know, you remember this context, right? It's actually sysuser on Linux. So we did look in that file in WinNT for Windows. We'll have to do the same on Linux. I am going to, I think, spawn another console for it or whatever. So I'm going to see this file in a second. Note that data is ignored and the registers are copied to the address. Okay, so data is ignored, address is where we are copying it. So this is ignored, I can put 0, and before that I can put like regs or something. But this is going to have to be a struct, so first we need to open that file. So let's user include, how is it called, sysuser.h. Okay, I'm not sure if, no, we actually are going to get the structure which we need, like this one, struct user. I think that's it. So yeah, that's fine. Struct user regs. I'm pretty sure, yeah, there are like these defines here. So you basically get the struct user for the architecture you're compiling for. I guess if you're doing cross compilation, that would be fine. If you're doing something for remote debugging a different architecture, you would have to play with this a little more. But we're not, so that's fine. Okay, so we'll probably have the regs. I'm not going to check the return value. I am going, however, to print the RIP register. And it's going to be P, because P is for pointer, and that will be regs. Regs, yeah, totally not redundant. Okay. You, and the reg is called, where is it, RIP, lowercase RIP. So yeah, that should be fine. Let's see if it actually works. It says 22222, which means it doesn't work, which I guess means I will have to check that value of ptrace. So man ptrace, it returns a long, so long that equals, and I'm going to do a long is like this, I think. Let's see what we get there. And we get -1, which means something did absolutely not work. And why does it not work? Data is ignored. Okay. It might actually work, but I might be getting the wrong structure there, which is also possible. Where is the return value described? Yeah, I'm looking for the return value. Return value, okay. All requests -1 and error no is set. Okay, perfect. If error no is set, then I can do... Where is p error? Man, p error. P error will give us a nice... I actually need the function for C. Perfect. My mistake is probably like super simple. Cool, so here we are going to do this with p error. P error, no, that's not good. Let's printf, p error, and here, that's fine. Okay, bad address. What? What do you mean bad address? My address is perfect. It's the best address ever. Okay. Bad address. By the way, it was uninitialized, but that's what was the address we saw. I'm going to do two things now. I'm going first of all to look at the structure if there's anything I had to initialize. No, this looks actually fine. I don't know what this magic here is, but I don't think there's anything I need to initialize here. Like, you know, get me this kind of registers or other kind of registers. So that's okay. Therefore, like in a second I started googling, seriously. Get regs. Wait, to the address in data. Why was I thinking to the address in... sorry. I actually had it wrong. Now it should be fine. Yeah, that looks way better. KrzaQ says this is some address. I'm going to note it down. Now, ASLR is enabled, so I think it's no, wait, I'm not compiled with Pi, so ASLR should not be enabled. I should get the exact same address, but I'm not getting the same address, which means ASLR is enabled. But even if ASLR is enabled, then I should have the 3 last digits the same. I do have them the same, so that's fine. Okay, so this is good. Now, what I guess I can do... Well, there are no other exceptions, so what I'm going to do is I'm going to continue with getting, so this is done. I am not going to do this check because I am not getting any other exceptions. I do need to read process memory now to get the bytes, right? And you can read process memory in 2 ways for, like in this case, right? You can either use ptrace, which we are going to do, or the other way to do it is there's a file in, if you have proc mounted, proc self mem. This is a pseudo file. It's not really a file, but if you open it, if you fseek to the right memory location, you can read from memory. And you can write to memory even if the memory is not writable, by the way. So this is a quite interesting interface. But we are not going to use it. We are going to use ptrace, and there is like peak something, peak text, peak data. Peak data is the way we are going to use. So let me again not check it. Let me do this. Ptrace, now the PID, and now we need to pass it two things. First, where to read the data, and second, what address is the data on. And the address is the first thing, so the address is going to be u dot, oh, it's a void pointer by the way, so I need to cast it. RIP, we are going to read RIP, we are going to read 2 bytes. Wait, how will it... No, how is it supposed to work? Ptrace peak data. Read a word at the address ADDR in trace's memory, return the word as the result of ptrace call. Linux does not have separate text and data address, so these two are equivalent. Data is ignored. So data is ignored, okay, and so address is given, data is ignored. And it reads a word, so the long, this return will actually be the value we are looking for. And we do not need to give it anything else, we just give it 0. That's fine with me, I just need 2 bytes from the return value. Now, my question would be here is, am I getting this like little endian, big endian? How is it encoded in red? Yeah, we'll see in a second, I guess. For x, I need only dot for x. I need only 2 bytes, and I'm pretty sure this will be the 2 bytes. I'm pretty sure I'm going to see OBOF. Unsigned short. This will be implicitly casted to int anyway. I think that's fine. Okay, run it and ctx. What? Wait, what? This. Okay. Okay, OBOF, exactly as I expected. So that's cool. So that means that if I want to get 2 bytes from it, I can do it like this. Unsigned char buff was the way I called it. And I'm going to, can I initialize it like this? I don't know. I'm going to initialize it like this. With red and, so first the OF. Okay, this is 1, and the other one is going to be red shifted by 8 and OXF, and I need brackets here. So yeah, I'm going to just like grab the first byte, then shift it by 8 bytes to the right and grab the lowest 8 bits again. Sorry, well, depending how you think about bits, to the right or to the left. Okay, and now I should have I can do this check, which I've done here. So I read the memory. Now, if this is an OFOB, we already have the registers read, right? So we can do the thing which was here. So U regs and R the X with a lowercase, and here the same drill. Then we add it and then we set it, but we set it again using the same drill. So .R, and we also need to move rip as well as we did on Linux. And now, well, we do not have thread context, set thread context, so we cannot do this. What we need to do is we need to do the ptrace. Ptrace, and now is where things get to be funny, I guess, because we need ptrace peak data. I don't know, what's like save data? No. Peak data. Poke. Oh, peak and poke. Like, that's the normal basic naming of things, like basic as in Atari Basic, and that's also the way I use in my return-oriented programming exploits. Cool, so poke text, poke data is what we want to do, not this, obviously. Pid, and how does it work? Copy the word data to the address in the trace's memory. So, this return here, right? Oh, wait, but we... No, wait. Do we need to... No, we don't want to poke data into memory, we want to set registers. I'm sorry, I got confused for a while. So we do this... do we do anything magic here? I actually expect the call to be identical to the one we had above. So I'm going to do this and keep my fingers crossed. Let's run it. And warnings, perfect. Narrowing conversion. Yeah, there are 2 narrowing conversions here. That's fine. Okay. Yeah, I guess I should use like some other type of cast, like a static cast or whatever, but this works fine. Okay, so there are a lot of debug messages and we get the result wrong. I know why we get the result wrong, and we will fix it in a second. For now, I'm going to remove this because it actually pollutes our screen and we don't need this anymore. This is better now. It says that blah 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 unused variables. I know that these variables are unused. I do not care about it. I am going therefore to disable the warning. Not something you do in production code. But you need to save the... Wait, what? Well, there is no... Oh, wait, no. Dash. Okay, perfect. You know what? I'm going to do, like... this. Yeah, that's better. Okay. Okay. That's one way to get rid of warnings, I guess. So the result is incorrect, right? As we remember, we are adding 1, 2, 3 plus... 222. No, well, no way, right? I mean, this is not the correct result. Therefore, what we need to do is figure out why. I'm going to tell you why, because we are relying on the Windows calling convention here, and on Linux, the first 2 arguments are not in the RDX and RCX registers. On Linux, which is using the System 5 calling convention for 64-bit, it's actually RDI and RSI registers, or RSI, RDI. I don't remember which is which, but we are doing addition here, so we don't really care. The return value is also in the same register. So yeah, let's do just this. And call it again, and we have the correct result, which is 345, so it works. And I guess we ported it to Linux in a couple of minutes. As you can see, the code, there's like less code on Linux because we do not have to handle the threads and quite a lot of events which were on Windows but are not here. And we also removed the way the child is started. We changed the way to actually use the normal fork because, yeah, fork is fine. And that's it. So I'm going to post the code on GitHub. If you have any questions, then pass them to KrzaQ. There's no mission today, by the way. And, oh, it gets worse. Yeah, it gets worse. Sorry. There won't be a mission next week either because there actually won't be a stream next week. Actually, there will be a break. I have like several events in my calendar in the next couple of weeks. And yeah, that means I will not be able to make a stream even if I would be, you know, in front of my computer. Sorry, so the next stream in English will be at the end of September. That's in a month. So sorry about that. Yeah, and I don't know yet what the topic will be. Yeah, but let's look at the questions. You will see the questions down here. Blame Drop writes, you might want or not to mention that something somewhat big news for Linux gaming today. Yeah, the big news is basically that there is a new version of Steam on Linux, and there are more games which are running now on Linux. I think they're using Wine on like a special version of Wine. Don't quote me on this though. And there is already a spreadsheet ready. I guess Dohan linked it to a list of compatible games. I'm going to give you links in the chat. The version is actually of the announcement. I don't know if the announcement is in Polish or Linux. Sorry, Polish or English. Polish or Linux. Perfect. Do check it or find that translation, I guess. And here's the doc of supported games. So yeah, like I also put it on the chats. Basically, a random story. You might know that Wine has been used in the past as well for like official game ports. For example, one of the Battlefield games for Mac, for OS X, was actually a bundle of a Windows game plus Wine, and that was, you know, an official one you got in a box. So it was quite funny. Like, instead of doing a full port, we actually did it like that. Cool. Blaine Drop writes, Hacknet tutorial at something if you're interested in Steam Play. Look here. Oh, I guess that's related to the previous topic. Okay, we're waiting you to hackistanbul.com CTF. I actually do not know what is hackistanbul.com CTF. See, let me look at CTF time. It's not in CTF time. So, what's Hack Istanbul? Okay. So the microphone will be. Oh, it's a. Let's see. Forensics exploitation and cryptography. Okay, it's hosting a worldwide competition. When? Okay, the deadline for registering is September 2. Okay, interesting. I'm going to pass it to my team. They might be interested in participating. So thank you for the note. There are quite a lot of CTFs, and that's good. I'm new to hacking. How can I start to learn hacking? Well, one of the things you can actually define is... Oh, wait, sorry. Oh, Disconnected writes that he might do a live stream next week in English about... Probably about, like... smart contracts. That would be cool. Yeah, I mean, go for it. I don't know on what channel Disconnected is thinking about, but yeah, I will probably advertise the stream one way or the other. To get back to the Twins gaming question, well, I guess the first thing you need to define is which areas of hacking you are interested in, because hacking is a pretty large area. You know, there's network security, there's forensics, there's cryptography, there's low-level exploitation, there's web, and so on and so on. So try different things. Try some web security, try some networking, try some forensics, see what you like. So yeah, get the basics of everything. That's basically what I'm trying to say. After that, well, you will know, like, you know, by heart, which areas are the ones you like, whether you like web security, or you prefer like crypto, or you prefer some low-level hardware stuff, right? And specialize in that, basically. One important thing to note is that at some point consider learning programming, because that is like super important to... There's basically, in my opinion, there's a boundary, and you cannot jump that skill boundary unless you know programming. That's my opinion, by the way. Yeah, that's like my high-level answer to the high-level question. If you have any, you know, like specific comments, just shoot me an email. Erno, yeah, Erno, we did check Erno using p-error, so yeah, we did that in the end. Okay, Viehu writes that code, and yeah, program, and even more program. That's kind of true. That's actually how I got into this, by programming. So that was the last question. I guess we are going to finish early today. I will upload the code which I ported today to my GitHub. And if you speak Polish, see you on tomorrow's live stream. Is going to be random topics. Otherwise, yeah, see you next month, or on like Disconnected's live stream. I guess that's it. See you, and I'm going to leave you with some music. Thank you to KrzaQ for being my moderator today, and for Disconnected to helping out as well, and as usually to Foxtrot Charlie. Yeah, that's it. Have a great evening. Bye bye.